Okay, everybody. Looks like everybody's settled in with some water and a little bit of a snack. It's 12 o'clock, so we're going to go ahead and get started today. Just so you know you're in the right place, this is the City of Prescott's WaterSmart Drop by Drop series, and we're providing a talk on groundwater supplies today, or groundwater in general. I'm going to go out to the internet real quick. So I say really quick. There it is. Okay. So we'd like to welcome you here today. We'll go through some of the basic housekeeping in a little bit. We have provided hard copies of different literature in the past, and we made just a few copies this time around, but I want to direct you to where the information's coming from. I'll give you a little bit more room here, sir. You're good. You can share it with me? Awesome. Thank you. So most of the information today comes from the Arizona Department of Water Resources. What you'll find here is they have programs. Excuse me, I have to turn this way. And it's off the screen. Programs, active management areas. Wow, it's not letting me do it. See if I can slowly get down here, jump over. Active management areas. It's too big for the screen. Okay. Well, at least you get to the first two steps, and from there you can see where the Prescott Active Management Area information is at. So that's the reference for today in case you don't get a hard copy handout. So my name is Leslie Grazer. I work for the City of Prescott in Public Works, and we're glad you're here today. We're going to start moving through the topic. So just so you know, you can bring your lunch. So if you haven't been to one of these talks before, we have a little bit of snack, but you can also bring your lunch, and you're welcome to eat in the library here. The librarians don't get upset about that. Reminder on cell phones. I don't think we haven't had a problem yet. And it's not really a problem. You just turn it down if it happens. We started videotaping these programs so that they can be replayed on the public broadcasting system in case somebody misses one or has questions about it. This WaterSmart Drop by Drop program was created because we could see there were a lot of questions coming up in the community, and this was even happening 5 years ago. You know, what's going on with water supplies? What are all these details? What are these names or words that are used that don't seem familiar? So we make sure that we spend a little time with the public, and we thank you for coming out. We do have a certain format. We go through a fairly short presentation. We do some kind of group questions, and then if you have something that's kind of burning in your brain that you want to ask, separately, we have different staff here to help with those questions. We do have fact sheets, so you saw those when we came in, and these are also available online and available on the city's website. And then the other two items, the things I did produce for you on the back table is the Groundwater Management Code. That's a helpful document. It's a pretty short overview for the state of Arizona, and then water levels. So how do we know what our groundwater looks like? Water levels are taken, and there's a unit specifically at the state where folks go out and measure water levels throughout the state, and that would be the map over there. You can take a peek later. And I think we went over everything, so let's keep moving along. We are here today, see if I can find the pointer, on groundwater. And we're more than halfway through the year. So now we're sliding down towards the end of the year. But the topic is a supply for a region, a long-term commitment to city water customers. So water supplies don't happen overnight. We invest in these things long before I was with the city, long before my predecessors were with the city. These are investments we make as a community. So on your fact sheet, we try to bring home a few points. One, groundwater is finite. The groundwater is a shared resource, so you don't own the water. We don't own the water. It's a common natural resource for everybody. You can own your well, though, and your well you are responsible for. And then the Prescott Active Management Area, and we'll look at what that encompasses. That's regulated by the state and monitored by the state, and it's the Arizona Department of Water Resources. So you'll hear that come up quite a bit if you haven't already heard about the Arizona Department of Water Resources. So let's get started with some of the basics. And groundwater, we could have a 3-part series on groundwater. There's so much to talk about. So I hope we'll hit some of the high marks here so that you have the basics. And then if you want to explore more, as I said, the Department of Water Resources has a whole website to talk groundwater or any kind of water you want. Surface water, it's all there. So what's groundwater? So it's the water that's in between, spaces and rocks and sediment. You'll have areas that are unsaturated, meaning that the water isn't in that area just sitting there, but then you have a water table area where water it's a saturated zone. It can occur in fractured hard rocks. So examples of that would be up in the Bradshaw. If you have a well up in the Bradshaws there, you're probably working off of a fractured bedrock system. So when you pull water out, you're taking water out of these crevices. If you're located out in Chino Valley, you're looking at a system that generally looks like that. It's in between gravels too. So you can see that there's different size rocks and materials that can make up an aquifer, and we'll look at that a little bit more. So once we know what groundwater is, let's look at some different aquifers types. So if this is the basement rock, meaning kind of the bowl that holds your aquifer, you can have a confined aquifer, meaning it's confined by some unit above it. And this water is usually under pressure. So if you drill down into it, it's probably going to pop out and be an artesian well because the pressure head is moving down this way and it's putting pressure on that spot and being able to move it up. It's thinking if we have any physics folks or hydraulics folks, that would make sense. And I think it generally makes sense to most people. You can have this confining unit where you have maybe not communication at all, or maybe a little bit of communication between these two aquifers, and this is an unconfined aquifer. So what you'll see here is a well will be put down and the head of the well or the water level will come up to the water table surface. So we have both these types of situations in this area. So if you go out towards Del Rio Springs, that's a pretty known spot, that the city actually has some property out there that still has water bubbling up from below ground. Another one would be artesian, just maybe comes to the land surface, and then these just a standard water level. So we'll be looking at that a little bit more today. So let's get into which area we're looking at, because when we talk about groundwater, if we talk too broad and like across the state of Arizona, as I said, this would become like a 12-part series. So we don't have time for that. But here locally, you're sitting, in this general area right here. This is Highway 69 going out towards Phoenix. And this is the highway going out towards, say, Paulden, Ash Fork to hit the I-40. So the Prescott Active Management Area was defined by the state of Arizona back in the 1980s. It consists, you can read it right here, 485 square miles. And this is the smallest active management area in the state. If you think about Phoenix and all the metropolitan areas that surround Phoenix, that's a very large active management area. So in our area, we're all friends with Prescott, Prescott Valley, Chino Valley, Dewey, Humboldt. So they're down here. Prescott Valley, Prescott, Chino Valley. And then all in here is unincorporated Yavapai County. So lots of people working off the same aquifer systems. And the key part is because it's labeled the Prescott Active Management Area, a lot of times people think that the city's responsible for this entire area. And that's not the case. We can only be responsible for our jurisdiction. And so we rely on the state of Arizona in that they pull all the data sets. They do a lot of the work. Here at the city, we just don't have the bench to have teams of people going out and taking water levels every day across this active management area. It's not part of our authorities. Internally, though, if it's one of the city's wells, we're watching those wells. Those get monitored regularly. Okay, let's keep moving along. So now you know the shape of the active management area. So here again, we're sitting down here on the map. And when we start talking groundwater, you need to know about the aquifers, and we talked about them a little bit. But we also have kind of a sub-basin boundary line that runs through this area here. And it splits the active management area into the Little Chino Aquifer area and the Upper Agua Fria area. So what happens here is that we have watersheds that move water into this area here, and it flows down and out towards Lake Pleasant in the Agua Fria itself. And the water supplies that are in the ground underneath the land surface, those also have a tendency to move this way predominantly. If we have wells that are hanging out over here and pumping, big, large production wells, they can kind of start capturing some of the water and pulling it across. But that would be part 7 of this series if we wanted to talk about that. And then this is the Little Chino Aquifer. And you can see Chino Valley's right up here. This is where most of the city's wells have been for a long time, is up in the Little Chino Aquifer. So I just draw those basic lay of the land items because they're important to keep walking forward. We're going to look at a cross-section of this area in just a moment, where we can see we have this is the mountain front area, and the aquifer, what it looks like if you cut a slice through and look at it sandwich style. What does it look like? And there it is. So if we consider, I'll just back up again. So we're moving from the mountain front out this direction. And then this is the mountain front side of the cross section, moving out towards Chino Valley. So now let's look at the basin itself. We know where the aquifers are at. We know what groundwater is. Starting with the basement unit, once again, that's kind of the bowl that holds everything. So generally, basement units aren't productive aquifers. However, if you are up here, say up in the Bradshaws in Groom Creek, then you might have a well in there, and you're working off of fractures for your water supply because you're not tapping into this one yet, nor this aquifer unit. So basement, not highly productive, but you need that part of your aquifer system to be there. So then we start looking at the lower volcanics. This is what we have in our area. So we have a lower volcanic unit, and we do have wells that touch down into it closer towards the city. So say the airport area, it's starting to just get into this volcanic unit a little bit here. If you drill shallower, you would hit the upper alluvial aquifer. So we'll continue on down. For this aquifer, they do talk about a confining unit in between, but it's really, there is communication between those two. So it's not like it's a hard and fast, nothing gets through. You might have areas, but with more recent modeling, so groundwater flow models, we'll talk about those a little bit later, they show that there is communication happening. So you can have water that comes in this area, as you can see, and makes its way down to the volcanic unit. Or it could be coming off of another area, Sullivan Buttes, and making its way down into the alluvial unit, and then potentially, possibly, down into the volcanic unit. Let me see if there's anything else on this chart that's important. And then just knowing your water table. So if you drill here, you're going through a certain thickness, and you might hit the upper alluvial and go down into the volcanic. And if it's under pressure, it might pop your water level up above the water table, maybe. Yes, sir.
How deep is that, say, varying from, you mentioned the airport area to, I guess, the
Like,
Chino Valley area?
how deep is it here versus here?
Yes.
This is going to be thinner, and if I threw out like hundreds of feet, and like the low hundreds would probably be, it's fairly thin in this area, so this is exaggerated. Up here, I would say airport is probably a thinner area here, and then this is hundreds of feet here. To help with that question probably a little bit, the city's wells are out in the Chino Valley area. We're down about 1,100 feet. Well, excuse me, let me back up. Airport area has a well that's 1,100 feet. And so that hit volcanics. So it went down and hit here. Where the break point is, I don't have that with me. And then out in Chino Valley, out here, one of our production wells was 690 feet. And it's just started to hit the volcanics. Okay, so since we're on some city wells, I'm trying to mix in, what the city has responsibilities for, the overall active management area, not, the Prescott city limits area. Yes, customers we serve out into other areas, and then the well field itself. So our well depths out in the Chino Valley area, back up, are about 550 to 700 feet deep, and our water levels, it pops up because we're in the volcanics, are about 200 to 250 feet. So they come up into the well. So moving to the next one is, how do we know these things about the geology? How do we know these things about the water levels? So they're from well drillings. So I brought in an example of a well log. And this one is actually, I don't know how clear this is to see. Let me get my orientation. So this is the highway. This is where a lot of the construction's happening right now. This is the golf course, and then this is 89A. You drop down into the Granite Dells Estates area, and that blue dot is the log for that well. So this is how we know. So we went through, this might answer your question the best, but it's just one point. So sands and gravels to 70 feet, down to 350 feet, decomposed granite, 390, granite and quartz, malapite, that's when we're getting to a volcanic. Malapite mixed with clay, no fun. More clay, no fun. And then back into volcanics, and then they hit bedrock at 1,000 feet. So just wanted to give you an example. There are wells all over the active management area. And so those are the things that are used to build groundwater flow models, so you know what geology to build into that model. Water level measurements when they're looking at declines or plus or minuses in water levels. These are the things that give us windows into the earth. So, as I mentioned at the beginning, the Department of Water Resources are the folks who have a team of people that's their job. They go throughout the state and look at taking water level measurements. So they were last up here. Well, let me see. There's different ways they go about collecting data. One of their big sweeps where they try to just hit everything was in 2017. So these are just a few of the wells. These are locations that the state goes with where these dots are at to collect ongoing records. And so the longer your record, the more valuable it is. So it shows you just trends, how things change. So when one person tells you, well, that's the way it is, well, in 10 years, it could be something different. It's just the way it is. These are living physical systems that we're dealing with. They're not hard and fast. They're not closed systems, where if you take something in a pipe and you push the water through, you pretty much know it's going to come out the other side, unless you have a leak somewhere, a break. So let's look at some of these water level measurements. So this area, and I tried to add these in because it's nice to have reference, but I'm not sure how easy it is to see, but I'll navigate you around a little bit. So this is going out 89A, we're in the Chino Valley area, and then you go out Road 2 South. We picked up a well here. So this again is a hydrograph that's in the 4th management plan, which is the document I referenced in the very beginning of where you might want to look. So on this side, you can see depth to water, and this is mostly how our brains think, is we want to know, okay, at 250 feet, 260, and then here's 330 feet. On the x-axis is time, so this is 1955, and I know this is small, so we'll try to work through this one. 1955, and it's 5-year increments, so 1955 to about 2012, there. So this is the well in that area. What it's showing is there has been a decline. It was about in the 260, we'll just call big numbers out, and it's down to about 320. And this shouldn't be a surprise. This is how groundwater systems work. You pump it, water goes out. We have rain, water comes back in, and the timeline can vary depending on where you are. Some things move faster into the ground. Areas take in the water faster, areas take it in slower. So down here, they say this is the southern part of the Little Chino Subbasin farming area. Historic water level declines were caused by a combination of agriculture and municipal pumping. So in this area, it was agriculture, and there's still some agriculture. So you could see that the water level was being pulled down. It went kind of flat for a little while, and then it had another pull. And this is pretty typical for this area. This is what we've seen. This is what's been documented in history. Okay. So one single point, everybody's going to say, all our wells are going dry. And you can't use a single point, because look at what this hydrograph does. So this one's going up. Let me get you centered here. So this is the airport strip. This is way too light, and I apologize, but I'll kind of tell you where you're at. Airport area, we have a recharge facility out here. So this is being influenced by recharge activities. And down here is the description. This well is in the Little Chino Subbasin near the Prescott Airport along Granite Creek. This shallow well shows evidence of flood recharge and recharge of reclaimed water supplies near the city's recharge facility. So we're not really going to touch on recharge a whole lot today because that's our topic next month. But it's interesting to see is you have to think about bigger data sets than just one point. So we would always see this, even if the city didn't have their recharge facility there, this well would be influenced by the waters coming down Granite Creek, and it would get pulses and show water level rises and then declines. It's almost like a breathing thing that happens. So then we see upward trends. I had one more, and if we have time, we'll go through it, but I just wanted to have you think about, you have to look at bigger sample sets unless you have a totally homogeneous aquifer, and I've heard there's places like this, but ours is not such a place. So this is a little hard to see, but it's just the aerial to show you where we're at, which I described out by the airport on the east side. So when you take all these water level measurements, and all these points are different water level measurements, the state synthesizes those to see what happens over time. And so it's important to know your time scale. If you see something that is just for 1999, that's really old. That was a long time ago. How about 2009 and 2010 data? That's just that one snapshot of a 1-year window. This one shows a little bit more. This is 1994, to 2010. So you can see that they're tracking the long term, and you can get different understandings and interpretations based on your length of data sets and over time. As we do, let me get us back into the right area. Here's Watson, Willow Lake area here, and you move out towards the airport. That's a plus an up water level. It's very tiny, 25.9 feet. So that is a really good indicator of our recharge facility has been working. We know that it's working out there because the water levels are indicating now, and that's averaged over a long time period. But that flux of water still has to find its way through the upper alluvial, down into the lower volcanics, or whoever's going to use that water next. Okay. I thought this would be super fun, but I can see that the pictures are kind of hard to see without the lights turned off. But if I turn off the lights, then the video goes poorly. So maybe we'll turn this off later. But what I wanted to show you here is that water level measurements, it's really pretty interesting. This was a water level measurement that was made up in Williams, Arizona, the deepest ever for Arizona. So the Department of Water Resources went out there. They had a huge spool, so it's got to be about this big around. It's sitting on the back of the truck like this, and it's anchored down because they're going to go down eventually 2,842 feet. Unbelievable. We take water level measurements in the city here. Give you some examples from our annual report. Looks like one of our deepest is probably 460 feet. One of our shallowest at our production wells is 195 feet. So 200 to 450 is how deep we go. Up in Williams, they have to go so deep for water, and you can't imagine the pumping costs. That's why they use Dogtown and Whitehorse as surface water bodies for their water supply. So these gentlemen decided, I think they were getting near retirement, wanted to see if they could get that big water level. So they built the equipment to do it. Down here, they fabricated a spooling mechanism to attach to the top of the well. And the person who was doing the camera work for him, taking snapshots of all this, that person had to put down their camera and be hands on deck for this measurement. And what this says here is the water level measurement was 2,842 feet. This is by far the deepest water level measurement in ADWR basic data history. After a successful measurement, the tape and probe were retrieved. So this is the tape, and then there's a device on the bottom of that tape. Were retrieved from the well and spooled back evenly on the base. It was a good day. So that was kind of a fun thing. So we don't deal with those kind of water levels here, but if you go up into the Flagstaff area, you will see things like that. So we keep moving forward. So we have an area. We want to know about the groundwater supplies. We need to know the geology. We have the very basics today. We have a alluvial aquifer, so that's a sandy kind of aquifer. We have a a volcanic aquifer. People come in and take water levels. We get a whole bunch of data, as many years as we can, and then we start looking at building groundwater flow models. How do you synthesize all this data and understand what's happening over time? So this is a pretty good block diagram. This was a USGS figure that's used. So we can kind of think of this as, we have the Bradshaws back here. We have our volcanics down here. This is the confining unit. And in our case, it's not blocking communication from one to the other. And this is our alluvial area. And then we have all this activity happening on the ground surface, whether it be agriculture or homes. And we put down wells and we bring up water supplies that we need for our homes and agriculture and industrial uses. So they have to take this visual, basically, and put it into cubes, a bunch of little cubes. And then the mathematics starts, and that's where everybody falls asleep. No, just kidding. It's computer models do amazing things, but we're not going to talk through the math of how they do this. So they're looking at how water moves through these blocks, and the computer systems look at it. So we go back to the Prescott Active Management Area. What does our model look like for this area? So if I can get it here, let's see. So I don't think I have the AMA boundary around here, but it's basically like this. And this is Prescott, so we're sitting over here at the library. Prescott Valley, Dewey, Chino Valley. So the grid system is all those blocks they built to start understanding the aquifer system. And why is there no blocks up here? Because that's really not an aquifer. So it's fractured rock, and wells are pulling from fractured rock. They want to know the communication that's happening in these areas, because that's where the aquifer unit's at.
Would the Verde River be it's not
Oh,
on
it's off screen. Yep, that's a good call. So if you go out this way, you'd hit Paulden, and then the Verde River would kind of wrap around like that. Sorry, I wanted to go off screen. So the Prescott model was first developed in 1995. It was updated in 2002 and 2006, and then again in 2014. And this was a big year because they started looking at flood pulses in the model. I believe that was the right year. I'm trying to think if I've been around a little too long to remember exactly. Yep, 2014 was the year. Okay, so what flood pulses, why are those important? Because those are the recharge pulses that bring water back into our groundwater system to reuse it again. And so models always have trouble with recharge fluxes and where they happen and how much they are. And so they found out, they started hitting, I'm getting into model speak, and I'll try to be careful. If you have a well here and a well here and a well here, and you know what's happening because you have a long-term record, then you have a target, and you know what you're aiming for in that model. If you have a stream gauge here and a stream gauge out here, once again, you have targets with real data that you know that you're trying to hit. And you see if your model is how well it's performing. And so when they started putting those flood pulses in, so we have a big snowpack one year like we'd had this past year, they can, through stream gauges, through activities in the wells, see how that affected it. Because you're either going to have recharge with that snowpack sitting on the fractures and filling them back up, and those people who live up there love that. That's a good thing. Slowly infiltrating back into the areas that they use water from, or as it's melting and running off, it's recharging basically the arteries that feed down into our groundwater system. In our case, we have some of the biggest rainwater harvesting systems in the area because we have Watson and Willow Lake. And so we can then meter out water as long as we're not so full we're spilling. And then if we're spilling, then we do some other things, but that's for next time. That's a prelude next time. So these are the things that are very important is for this area, I think the Prescott area is very fortunate to have this many models and it continues to be worked on. Because the first time you build a model, mostly you're just trying to figure out where your data gaps are. You built it, you're like, oh, it's pretty good, but you have gaps and you're not quite sure how to fill them and you had to make assumptions. So as you continue to work that model and bring in different ideas and better understandings and longer term records, you can start tying things down a little bit more. Let me check my time, make sure, yep, about time for me to stop. So let's go just a little bit further with the model idea. So this is the active management area again, the outline. We're sitting down here. And let me back up again to orientate. So if I showed you this grid area, basically now this is the same grid area here. So what the modelers looked at is they make kind of these heat maps to understand things a little bit better. And how transmissive the rate at which groundwater flows horizontally through an aquifer is in feet per day. And so the warmer colors say there's less movement through here, and the cooler colors mean there's more movement through here. And that can kind of mean two different things. If we have a whole mess of volcanics up at here, which we do, if you remember the cross section, we had alluvial through here, which they didn't even bother to model. You get here and you have some more alluvial, and then you start hitting some of those volcanics, and then you have a pretty big spot here. Water's gonna move pretty easily through volcanics. Yes, ma'am.
Could you show what the path would be from the wells in Chino Valley to the Prescott water production facility?
Yeah, you can do that. Okay, so basically the city's well field is out here, so it's not all clumped together. It's moved towards a central production facility where you make sure you do all those things you're supposed to do, like chlorinate, blah, blah, blah. And then from there, transmission lines come into the city. We have 2 storage areas, and that continues out into a whole bunch of different storage tanks. So the city has one of the most complex infrastructure setups. Is that what you were looking for, was how we move water in? No?
See, so the transmissivity decreases somewhat from the wells as you get towards the production facility, but it's not in the warm colors.
Right.
Okay.
You know, what's interesting though is the city does have their, let me see how close I can get to the screen and see if I can locate myself the best I can. So Watson and Willow are right in here, and then the city has the golf course area, and some of the airport wells are in that area. So it's in a little bit cooler area, but it's still not bad. And I always find this really interesting is that, you know, for a long time, the city, if you go back into the 1864, I don't know if we did a history unit this calendar year, but last year we did, is that it was a constant battle. You know, it was just like, okay, water supplies, what are we gonna do? Well, they were sitting on fractured hard rock. And so when it became, you know, like, oh yeah, the agricultural team out here who were making a living, you know, doing agriculture had lots of water. So the older documents talk about how cities should consider using wells out in Chino Valley and bringing it in. Del Rio Springs, because it was so visible, it was coming up out of the ground. It was like, oh, we need to bring water in. But you can imagine the heartburn to some extent, because people were like, wow, that's going to be expensive to move water, not only that distance, but uphill. And so some things, you know, don't change over time. You know, we have to contemplate infrastructure and water needs, but, you know, having water is better than not having water, right? So they're like, I think we'll pay to figure out how we're going to move water from here back up and into this area. And I'm going to try to wrap up. We're almost there. So how does the Department of Water Resources use the data that they collect about the groundwater system? They do the water levels, like I mentioned. They analyze the levels and other data sets to aid in future water planning. And they develop groundwater flow models to help us keep managing our water supplies. When I think about if I lived in another state, now they're getting pretty good, but previously other states didn't look at long-term management of water supplies. And Arizona's been working on this the 70s. They were all arm wrestling with each other and trying to figure out what they were gonna do. 80s, they brought on the Groundwater Management Act. And then here, it's basically this. We're in our 4th management plan for this region where we all have to try to play ball, you know, whether you're Dewey-Humboldt or Prescott Valley or not Little Chino, but Chino Valley. We all have this management plan. And this keeps guiding us toward better futures. These kind of things don't turn around overnight. So that's where the bench is. The bench is down in Phoenix, basically. That's where the scientific teams are that manage the entire area for us. Here locally at the city, we do our part to not only meet those requirements, but do our best to exceed them. So when they told us, hey, you know, you need to be looking at maybe doing more, using more renewable supplies, the city was already there with their effluent supplies ready to roll. Then they went into their final discussions and purchases of Watson and Willow Lake as the other renewable supply to keep our system balanced. And we're back to just going over the basics of groundwater like we did today. So I'll stop there. Apologize, I only went 5 minutes over, but if you have some questions, you just had a whirlwind trip. Yes, ma'am.
Where does the city have to be on groundwater levels before they make the decisions to start tapping into the water by K4, the Big Chino Basin? 'Cause
Where
I
do
know
they
you
have
write
to
something.
be? I don't think there's a set level. Right now, as I was reading off the water levels that we're working with in the Little Chino area, we don't have a condition where we feel like we have to immediately go and get water, physical supplies out of the Big Chino. So when that point will be, that will be a lot more discussions, a lot more following the data sets, but the city's not, the general area is not in a critical condition where they have to start thinking about building infrastructure in the Big Chino to bring supplies in.
Okay.
Yeah, I wish I don't have a crystal ball. So
Okay.
that's a tricky one. Yeah, that's a good question though. Yes, ma'am.
I live in Prescott Valley, and you mentioned that the Prescott EMA covers the Prescott Valley area as well. And they're under I get the general impression that they feel that the water under Prescott Valley is that the Agua Fria?
Upper Agua Fria, uh-huh.
Yeah.
Yep, subbasin. Mhm.
That they can, it's going to be decades before there's any impact. We have this growth boom going on over in Prescott Valley, and so there's concern that the water use is going to lower that aquifer, and that yet when you read articles in the paper or whatever and go to the council meetings, you hear that they feel that there's sufficient supply of water to last us for decades to come. What is your impression?
I think decades is a reasonable time frame because kind of where I ended up a little bit is Arizona's been in the water management game for a long time, and I know that just going back to the 80s doesn't seem like necessarily a long time. But the flip side of that is that water management doesn't end. So even though we feel like we're pretty comfortable, we feel like we have decades, we still need to be looking for that next bucket or how we're going to make sure things stay sustainable. So can't necessarily speak for Prescott Valley, but what the state of Arizona, in working up these models and such, this area is generally considered to have 2 million acre feet below it. The reality is, though, that we saw there's water level changes, and so we know we have reductions or drops in how much we have in storage. Realities of science are that not all that water can be sucked out with a straw like you do a glass, and you say, well, got all that soda pop out of there, left the ice cubes, so there's always these ongoing things. And so I think that when you're a water provider, you look long term. And so if everything's looking like it's tracking pretty good, great. The state's management plans also tell us, you're doing a pretty good job, but you need to keep working. And so it'll be a generation after me, generation after that. They'll keep looking at how things are going because their conditions may change. I don't know if that was an answer, but I think it's an open-minded, you have to be kind of open-minded that,
And I assume that a lot of that has to do with whether we're in a drought or whether we have, like you indicated earlier this year, we had that snowfall.
right, a little snowpack that we all,
Yeah.
where has that been for years, right?
Yes, exactly. And so I assume that a lot of that has to do with the flow that we get from the
Yeah,
weather.
yeah. And I think the reality you have to look at too is, these things just don't fill back up overnight. It's a pulse of water that's kind of moving down, making its way out towards well fields. So you have to just keep watching the system overall. Yes, sir.
So
You're the one.
Prescott Valley has just recently drilled 2 or 3 new wells, and I'm assuming that's because there's lower transmissivity from your transmissivity table.
Yeah.
Because there's lower transmissivity, it doesn't communicate back and forth very well, so they have to.
Yeah, this is the Glassford Hill area. So it's neat that always pops. It's a volcanic structure. And so you can move water pretty easily in that area. It's kind of a recharge area, but we know that the water moves this way. And even though this is blue here, you have to think about thickness. What's the thickness of the area? Is it really moving, this monster load of water, or is it really just very thin bank sediments that are showing that they're transmissive? So there's a lot of ins and outs of these things, but I understand what you're saying. They have done some recent drilling. They've had success because they know they're right by the Glassford Hill volcanic area, which is good. Saw your hand come up too. Yes, sir.
Hi, Leslie.
Hi.
Question concerns the effluent at the airport. And HWR encourages you, or maybe even requires you, to put your recovery wells near where the recharge is occurring.
Yep.
So the concern then could be with contamination of the recovery well with the effluent that's being recharged. The recharge is into the alluvial unit, and your recovery wells, I believe, go into the volcanic?
Let me look at my notes here real quick. I would say yes. I didn't check all of them, but
And
they are
if they
deeper.
do-
They're in deeper areas because that's where the real production is at.
If they do, how good is the confinement between the alluvial and the volcanic in the area where the recharge is occurring for protection of the water supply?
Okay, so let me see if I don't have a very good one let me see if we can locate here. Okay, so the recharge facilities, and I apologize, obviously we need a darker room or big bright slides. So they're at the recharge facility itself. The well that we were looking at in one of the slides, that one is solely allowed by the state. It's permitted for recovering water solely for golf course use. So we take that back out. So that's the closest one. We also have to make sure we're looking at the water quality on that as well. So then the airport, the ones that are for production, have to be in a 1 mile safe harbor area. So those are further out. One of them right now is upstream. So the recharge is actually going to go the other direction. And then the other two, they're so deep. I would say the bioremediation, I would say the filtration that happens in the sediments is probably pretty good. Now, the question I think is, when we pull water samples, because if we're producing water for public use, for potable use, we have to be sampling those wells all the time. So that's primary and secondary. So the question then comes into what are the other things that aren't required by the EPA to be sampled for? But we know that we meet all the EPA standards for primary drinking water standards and secondary. That's a pretty tough question because I'm not a water quality expert to say, we can say, yeah, that's fine. If we saw bacteria levels coming up, other things that we have to sample for, then we would know we have a problem. And that would be similar to if you were on your own 1 acre property and you had your well and your septic tank. And if you were too close, then you're going to be pulling. And that's, I think, we're pulling anything that we don't want to have in drinking water supplies.
So you're saying that the well that is really close to the recharge basins is only used for golf course?
Absolutely, yeah. That's all.
And
It's
then the other
permitted.
wells are, you said, about a mile away?
They have to be in basically the 1 mile area of impact.
Okay.
So we're recycling our supplies.
And then you're saying that the flow is away from those wells?
One, right. The other two so one's off of Ruger Road. That's going to be slightly influenced, but it's so far over that it's hard for me to imagine that we're recharging, that it's just kind of spreading out like that. It's going to take a preferred path, which is going to be Granite Creek. But if it brings up water levels over time, that's what we're looking for. Or that's also what the state is actually looking for. They're saying use more of your renewable supplies, your treated effluent, and your surface water supplies. So we're also putting surface water down in that same facility. We'll have to have lunch sometime and see if we can talk out the details. It's a good question. Yes, ma'am.
Despite the fact that it's decades for Prescott to run out of water, and apparently also Prescott Valley, we know that wells are going dry on the edges of the little Chino. And as you said, it's a shared resource, so it seems like as responsible municipalities, we need to think about the entire aquifer. And so now my question part is, the city of Prescott has the dish lip model, which seems like a really good tool to help predict, to know how much water we're using now and how to predict for the new areas.
Mm-hmm.
Would it be a good thing if the dish lip model could be expanded to all the municipalities. And then if it were, could that data be integrated with the Prescott Active Management Area model?
I have a dream that one day you can, like all communities, I think we strive to have, use our technologies the best we can and make sure we integrate things. So I think that's a good path. So we wouldn't disagree.
So it's something we could work.
We work towards, yeah. We did our first big lift was to integrate everything into one long-term kind of prediction. What does it look like, and give us the ability to look even beyond city limits a little bit and see what does that mean. So I'll jump over here. Oh wait, can I go this way? Because he did have his hand up first. Yes. Yeah, you're up.
I think a good way to look at it is something that Ed actually presented in this room several years ago up here, the USGS graph that shows when you first start pumping, it's all coming out of volume, and as time goes on, the amount you're taking out volume decreases, and you're capturing more flow that's going through the system. And I was looking recently at ADWR data graph, in our area in Prescott and there was about 10,000 acre feet that was recharging and 10,000 feet that was going to outflows, the springs and the underflows.
Steady state. Mm-hmm.
So it was all in balance. And then since that time, they're saying now, or as of I think 2010 or 12, the natural outflows are now 5,000 acre feet per year. So that means we've captured 5,000 acre feet per year of that. It's like you're standing next to a river and you're pumping out some of that water that's coming down, and there's less going down. But as far as volume, it's saying since 1938 we've pumped out about 400,000 acre feet. So I guess when I look at the big picture, it doesn't seem like the whole system is sustainable. Really, the only sustainable part of the whole thing is the natural recharge of 10,000. And when we take that, actually, downstream natural flows, suffer. And even the recycling, actually, all sewage or effluent that's recharged, that ultimately came from groundwater in the beginning. So that's why I was such a big advocate that we have to reach and try to find another sustainable water supply that will actually make a true water balance in our aquifers. So I was just making the comment.
I was just going to pull out a couple of things that you had mentioned, and then maybe we'll break for that last 10 minutes, unless there's more questions. But I didn't, as I said, this could have been like a 3-part series. And we didn't touch on cone of depression, and that's an important concept to have when you're thinking about groundwater. To keep things, the realities that we live with is that we have stationary communities. We don't migrate anymore. So we are going to have impacts on the systems, whether they be surface water, and we did that before, when everybody was trying to drink out of the creeks and the livestock was trying to drink out of the creeks. But the population was much smaller. I think it's interesting to watch over time is the efficiencies, and I'm not quite sure who might have brought it up, but part of us managing these water supplies, if we know we're a stationary community, and generally growing, communities grow, we know we have a pretty tight water model that we can see how things are being affected. Then we also look at what is our responsibility as water users of the supplies. And so even if we said everybody, go home, go back wherever, we have families that have been here for 4 or 5 generations, right? But if everybody kind of went back somewhere, the system here would still take a long time to recover. So the effort should be in that we each take our responsibilities to help level things out and work towards better futures. We keep watching what we think might happen in the future. Is it going to be hotter and drier? Well, then we should be looking at how we are more efficient. Is society's giving us better conservation tools, better plumbing devices? We can do that. We know we have neighbors across the seas that use less water than we do per capita per day. So we keep finding those opportunities.
I think the thing is, throughout the world, the aquifers are dealing with the same problem. It's just the phenomenon of hydraulic
That's a good point. That map there, Arizona, everybody's talking water. It doesn't matter what basin you're in. Everybody's looking at, ups and downs, a lot of red points like, oh, that's going down. And so how are we managing this over the long term? I will kind of wrap up with, because you brought it up, the fourth management plan, again, if you want to dig into this more, there's a table that shows the historic water demands by sector. So it's really interesting over time to see what that looks like and then balancing it back against how much is recharged. So these are two great pieces in that document. And as I said, I just was conservation of paper. I didn't produce a lot, but I know that you can find it on the website or contact us and we're happy to do that. So I'm just gonna, here we wrap, I'll grab your question maybe on the side.
My question was that last slide with the dropping levels, but that was also the area that you said was more permeable. So that seems to be a disconnect to me. Why are those like -30, -24, -34, where the water can go through easier?
Because we're pumping water supplies from that area. So the natural system has to catch up and refill. So we're gonna see water levels change over time and some will pop. And so it's very transmissive. That's why it's good to, if you're trying to move volumes of water, 1,000 gallons per minute, it's a good place to be. But those areas are gonna go down because that's also, the history part of this is, this was like the breadbasket for the Grand Canyon and for a lot of other areas. So water level declines have been happening long before this was the community of a size it is now, before Prescott Valley grew, to the area size it is, Chino Valley. So that's kind of the reality. It's easy to move water out of those areas, but then you also have to wait for recharge and things of that nature. So
over time, has this been getting much worse? Like, when was this measurement?
Oh, so this is averaging out what it looks like from 1994 to 2010. And this is another figure right out of that fourth management plan again that you can see. It's actually a pretty fascinating read. There's some things you think will make you fall asleep at night. I don't know, for me, it's fun to read it. Even though I've read it many times, I always pick up something else and I'm like, well, that's something to think about. So we better wrap this up. We're down to like 6 minutes or so. So please help yourself to any vegetables or the materials in the back. And thank you for coming today. We're here for questions, a lot of us.
Thank you.
You're welcome.